Oh, but we also have functions. Yeah, we said there are also functions that can take that can accept values, right? That accept information. So here we have uh, ask yes no 2 accepts a string as input. Okay. Um, so the way we make one of those functions is, first of all, in the function prototype, we have to say what kind of information it likes. So it likes information of type string, and question in this case is the is a variable name that we can associate with the input, and then you have your semicolon. Okay, so it looks similar, and char is our return value again. So our definition for this guy is char ask yes no string question. Again, the function header matches the function prototype, except that there's, instead of a semicolon, we have the function body is what comes after. Okay, because what we're going to do again is, when we see this ask yes no call, we're going to call it, first of all, we're going to give it the information that it needs. It needs a string, so we're going to give it a string that says, do you wish to save your game? And then we're going to jump down here to where it says ask yes no. And basically what happens is a copy of the string gets made and gets loaded into this question parameter. Okay, so now this is just like another variable that gets called down here. So in this case, when ask yes no 2 gets called with do you wish to save your game, when we go down, we jump down here, and question is automatically loaded with the value do you wish to, with the string do you wish to save your game. Okay, so we go down here, and this acts pretty much like the previous one, except that we have our own question. You can load whatever question you want in here. Let's see. So so you can see this makes it the function more powerful, right? So basically, the idea is whenever the function gets called, the way to think about this is when the function gets called, we basically create a new copy of the function with its own, local question variable, and this parameter, this question parameter, and this response too. Also, these so the parameters and any variables that get declared inside the function, they only live as long as the function lives. Okay, so for example, I couldn't do something like cout response 2, even though response 2 is a perfectly good, in fact I'll copy it just to make sure. Control copy, Control C. Okay, yeah, cut and paste. And even though this is exactly the way it's declared down here, and I can use response right here, I can't use this variable up here. It says, it'll give me an error saying it's undefined. So you can't, any of the local variables, or the same thing with question. If I said cin question, cin question, even though I can use question without any trouble down here, I can't use it outside the function because it only exists inside here. Okay. Now, that doesn't, now, again, you can still pass values in. So we're not using the variable name question here, right? But we can, when we pass that value, that gets loaded into question. And we can't use response 2 up here, we saw, but if we return the value that's in response 2, then it will return a char for us, and we can actually assign answer 2 this value, ask yes number 2. Okay. So yeah, so this idea is called encapsulation, right? We want to keep, and the strategy, it's actually a strategy, you know, that's designed to help programmers, because what you want to do is the information that's relevant only to this function should stay only in this function, right? It's not, you don't want things messy to the point where, you know, you can go in and change some value in here, and then it's going to change how this function behaves, right? So you when it makes sense, you encapsulate, or you know, keep data private to a particular function. Okay, and actually in this program, and this is like generally a good strategy, all of the variables are local. They only exist inside these particular functions, right? Char, answer, all of those. Okay, so that's encapsulation. And it's related to the idea of abstraction I talked about in the last video, because you want to hide details as much as possible. All right, and abstraction is about, you know, thinking on the higher level, not so much on the detailed level. You know, you have to get into the details at some point, but that's what those, you know, functions, that's why you build the functions. You build separate functions to handle different details. Okay, so now when you look at your main function is nice and clean, because these you know, these functions are called separately. And also notice this ask yes no 2 is actually an improvement over ask yes no 1, right? Because it allows you to decide what your prompt is going to look like. So it's a good, I mean, it's not like 100% rule, but it can be very helpful to be able to write your function in a way that it can be used more flexibly, because that accommodates the idea of reuse, right? It's easier to reuse functions if you can make them more flexible by sticking in variables and stuff like that. And that's really part of the idea of functions also, is that you can reuse functions. If you write a nice function, a nice flexible function that does a task that a lot of people need, then it can be used over and over. And this is helpful because it makes programmers more productive if they don't have to, you know, rewrite the same little bit of code for each function. It can improve the software quality, because if you have a function that's used over and over and over, then it's been tested over and over and over. So it's more likely to be tried and true and high quality. And you can also improve the performance of it, right? So working on that little function over time, you can get a nice high performance piece of code that can be reused. Okay. Yeah, so that's, and actually I'm going to talk a little bit more about reuse in the next video, but I think that's enough for this one.